So here's a tutorial on how to do a parallel lace for the top curved surface of your box. So if you open up your part file, it'll look something like this. If your part file does not want to open, if you get an error, make sure you open up Inventor first, quit Inventor, and then go back into Edgecam, and then that is the little magic trick. So we're going to rotate this. The box is in the milling machine with the hand clamp vise. It's in the milling machine in this orientation. So that means we need to put our CPL down here. So that's the corner that I'm looking at. The first thing that we're going to need to do is auto stock or stock the box. My button is here. Yours might be over on the far right edge over here. It should look something like this. And then we have automatic stock should be checked. It is, and click OK. Yay, now we have a box around our box. Now we're going to need to go into geometry and create CPL. Click origin, name it something, or just push a bunch of keys. And we want our plane to be through 3 points. Everything else is good. Click OK. Now the first point on the plane is the CPL corner. You can see the red box around it. That's what I'm looking for. Click. Then we go over to the far right corner. Click. And our third point is up here. Click. And then we go back to the original. Can I find it? Where are you? Sometimes if you rotate it, you can find that again. Oh, there it is. And now there's my CPL. Green is going in the Y direction, red is going in the X direction, blue is going in the Z direction. Looks fantastic. So now we're going to go over into manufacture mode. And discipline should be set to mill. Machine type should be ProLite. And that's all that you need to look for. Click OK. And wait for it, wait for it, wait for it, ding, there it is. Now we need to go into parallel lace, which is this key up here. So we click on that, and it says digitize geometry. So we're going to click this once, and I'm going to push the enter key, and then the enter key again. And then it will take us into our parallel lace operation. Deal. We're going to set the mill type to optimized. Percent step over should be 25%. If we do anything more than that, it bogs down the mill. Tolerance is good. Angle is up to you. If you wanted to cut at a diagonal, put it at 45. If you wanted to cut straight, then put it at 0. So I don't know what I want mine to do. I'm going to do mine at 90 because it's cool. I'm going to do mine at 60. Yeah. Then go to tooling, feed rate. For the first pass, it's probably best to keep your feed rate at 20. Plunge feed of 10, well, no, only got 30. Plunge feed should definitely be no more than 10, and you can set your speed to 4,000 or 5,000, somewhere around there is fine. Position is 0, diameter is 0.25, so that's okay, and corner radius is 0.125, and that's what gives you that 1/4 inch ball mills, what we call that, because it looks like a ball on the end of there, kind of. Then we go to depth. We can leave that as it is. It's a clearance of 0.25. That's fine. Click OK. And you get to see the magic. And it's almost here. Oh, that is delicious. So there we go. That's how it looks. If we double left click over here. Oops, sorry about that. Right click. Forget that. Anyway, that looks great. So now we're going to verify this. If we click on rapid results, then we can verify this, and it's going to look fantastic. And click play. Yay! How neat is that? It's delightful. So let me make that window bigger so you can see how fantastic that really is. There it is. And that is verified, so that looks good. The last thing you need to do is export your code. So look for this button, NC Generate Code. Click on that. We don't need to name anything, just click OK. You want to put your name in here, enter program ID number, we don't have that. Let's wait for, programmer's name, that's what I want. Mr. Codes a lot. And it's going to create your code. And you're not done yet. We don't want to have a tool change, so let's get rid of this. Yours likely says N2, N4, N6, N8. That's fine. We're going to delete that. And what I like to put in here is a little Z 0.2. And really all that does is it makes sure that when you zero it, it's going to lift the bit up for you automatically before the spindle starts. My spindle speed changed. I don't know why mine did that, because I had set it to 5,000. So you might want to just verify that yours is set to 4 or 5,000. Either one of those will work fine for this. I'm setting mine to 5,000. Everything else looks fine. And if you so desire, it's always a great idea at the end of this thing to put in and I can actually type in right here, this is before the MO2, I can type in an X to Y2 Z2, and that will lift it up. It's okay to have that on the same line as the MO5. The MO5 is just turning the spindle off. So the spindle's turning off, and then it's going to move up and out of the way. So that's always a fine idea to do. Then we go up to File, we save this as, and save it into your flash drive, which you're going to find somewhere in here that you put in there. If you don't have your flash drive in there yet, save it into your own personal folder, wherever you want to save it. And you might want to call it something like Top Box, or Top Box Curve is even better. And then put it on a flash drive, load it in, and verify it. When you verify it, you need to make sure that it looks the way that you want it, and we should be all set.